Hello everybody and welcome back to Python for Aerospace. In today's video we're going to use class and methods to create whatever 4-digit series airfoil you prefer. So let's start right after the intro.
It's one small step for man, one giant leap for mankind.
Alright, so let's start and pick up our code from where we left last time. Uh, so most of the work is actually already done because we have already the algorithm that generates the geometry of whatever airfoil we want, but we would like to have a class where we can have everything more compact format. Okay, just to store all the information in different objects whenever we create a different airfoil. So first of all, let's define a method, okay, that we can call, for example, this method Naca for digits geometry, sorry, coordinates. Okay, so what this function will do is gonna take as an input our Naca 4 digits series number and the number of points we want to have to construct the geometry of the airfoil. So in our case, we can set up, for example, 300 points to begin with as a default volume. So let's add some comments to the function. I'm gonna use my notes, okay, and you can find all of these in GitHub as always. So okay, so we have some description, and we can start by moving out of the function all the packages and libraries that are needed for this task. So NumPy, matplotlib, and OS are out of our function. Since Naca and coordinates are our input values, we don't need to write it down here. We can remove them. And then we can give a tab to all of this lines of code, which are now part of the function itself. We can also move this out of our cell for the moment. Let's put it somewhere where it doesn't bother us. Okay. So we have our function here with our inputs. Here's the algorithm, okay? And then we can return our outputs, which in our case will be, for example, x and y for the x and y of are the coordinates of the geometry of the airfoil. Then we have the chord, the camber line, and the Naca series, okay? Number. Good. I would like to add one more thing to this function, which is a check that sees if the input variable, okay, is formed by 4 digits. If it's not, the function will raise an error, and then it will fail. So you have to be careful. So let's write down. If the len of Naca is different than 4, okay, then our function will raise an exception, and it will say Naca is not a 4-digit series. Okay, good. Let's test the function. It's very simple. Then we call the function down here at the bottom. We can create we can use again our 4418 airfoil, and let's run and see if we have any error. So the function seems to be working. We get our outputs here, as you can see. We will test later if they are correct or not. Very good. So how to proceed from here? We could create a class, for example, right? Where which is called at the end of this function. So in such a way that, for example, we can create an object called, for example, Naca 4418 equals to this, and the output will be an object created by the class. So let's define the class first. So we can create a class named Naca, and we can initialize it by defining the method init like this, which takes as input self. And what else does it take as an input? Well, I would use these values as inputs. So yeah, and these values are then stored again in self, which is this variable which is shared throughout the whole class. So whatever other method I define here, it will be able to access this variable self. So, and self contains x, then contains self y, self dot c equal to c, self dot big C equal to capital C, and finally we have self dot, I will rename it as series equal to, and also this one will be series. And one variable I'm forgetting that can help us is the number of coordinates. So we can store also the number of coordinates in here, self dot, like this. Good. Save. And now let's see if we can initialize our object. Okay, so we could call the object here and create it. Let's test and see if we encounter any error. So yeah, we have an error. I will go through it and search what the mistake is. All right, now that I found the mistake, we need to add the number of coordinates as well as an input in our class. So let's add it here and save it within self. So self is equal to, okay, number of coordinates. So good. Now I think this should be working. Yeah, almost. And let's add finally another method that will allow us to plot on demand the shape of the airfoil. Okay, because right now we set our function apart here, so we didn't use it yet for the plotting. So let's create within our class another method called plot, and yeah, it's gonna take an input only self. Oh, okay. And the code that goes within it is already here. We wrote it in our previous lesson. Let's copy paste it and make sure that all the indentations are correct. Now notice one thing, that all our variables x, y, c, capital C, and so on are preceded by self this time. So before in the previous lesson you had just x, now you have self.x, self.y, and so on. And here instead of Naca you have self.series, and that's it. Okay, so I think we are good right now. Let's run it, and we don't have any mistake. So for me this is a good sign. So let's try now to check if the object contains the attributes that created before. So let's type name of the object dot tab. Let's hit tab, and yes, we can see the content, right? Let's print, for example, the x coordinate. It's right here as we wanted. Good. So let's also see, for example, the geometry of the airfoil. And this can be done very easily because now we have our plot method that we defined. And if we hit Shift Enter, yes, there it is. That's our airfoil. We can create as many objects as we want. As a matter of fact, we can copy, for example, this multiple times and change the name of the airfoils, or change the airfoil series. So we can do 24 18 or 2412 actually. I like it better. And let's create another object like this. And then we can have, for example, 0012. Okay, and let's run it. Okay, yeah, there's a small mistake here, and good. Yeah, you can see 3 different airfoils, and they are looking good. They're correct as expected. So again, thank you very much for watching. I hope you learned a little bit about methods and classes. In the next lesson, we're going to proceed and use the X-foil library to calculate the aerodynamic coefficients around whatever airfoil we have, and we're going to also try to store all the functions used to calculate the aerodynamic coefficients within our class here, Naca, so that we will be able also to plot on demand the curves of the lift coefficient, drag coefficient, or the pressure coefficient as well, for example. So I hope you see you in the next video, and talk to you later.